for electricity, right? So basically, chemical reactions that will produce using electrons flow through a path or through a wire, something like that. Okay, that is the point in this topic. Or meaning to say, we will use some devices to clearly understand that the application of chemical reactions are used to produce electricity. So what are those devices? There's a lot of devices to produce electricity. Voltaic cells or galvanic battery, okay, or something like that, and it's composed or made of certain metals that are involve a chemical solution in the wire to produce an electricity, and then will connect the incandescent pad at the center of this wire, and this wire will be connected to the poles, the metallic poles of this interconnected with or connected or contacted with an aqueous solution of electrolytes. Need to draw, or need to example copper sulfate wire on each cell. We need to say a cell is composed of a solution. We need to emphasize that somewhere along our discussion as I draw. I'm going to get a blank sheet of paper already so that we can further have an overview or shall we say clear emphasis of this, and then it will produce electricity or electrical energy. Okay, so that we have light energy, or so that our fluorescent, okay, will be lighting up, and our also mechanism bulb will be lighting up to produce lights that we can see clearly the world. So okay, so that we can have light at night, okay, because we have daylight in the day produced by the heat of the sun, right? What I mean is the light only produced at night, and of course also not only that, it can produce conductance to our conductance, meaning produce electrical movement or electrical energy, so that our gadgets, devices are functionable or can operate properly to its operating conditions or parameters. For example, my laptop can operate, okay, my mobile phones, any kinds of gadgets that's driven through electrochemistry really, okay, because most of our gadgets and devices are composed of chemicals, okay, and these are chemicals that will have to react with each other inside chips, inside your mobile phones or whatever gadget, printed circuit boards, okay, inside that, and in that, science will be operating in its normal condition because it's designed for that applicability to operate the gadgets, okay? So before it will become a product, it must be designed properly. Of course, if you try to isolate the physical parts and accessories of those gadgets, then you can see that printed circuit boards also, okay? And the microchips inside, like that, and the battery also, the built-in battery, okay, the built-in battery of the phones, sometimes laptops also have built-in already, right? Okay, it has really positive and negative poles due to the conductive elements or metals. Okay, without the conductive elements and metals found in the microchips. Okay, so that's why it should be properly designed according to its operating conditions, okay, meeting the requirements of the NSC number 70, like that, National Electrical Code 70, and other standards from UK, something like that, or USA, or any ISO standards that it will follows. Okay, ISO meaning International Organization for Standardization. Okay, get the point, something like that. But in our discussion, we will not focus more on the standardization, international organization standardization, and some standards for that. We are just focusing on the concepts and theories through the why we can produce electricity or why our laptops, gadgets are functioning, okay? So that we can enjoy surfing the online world, social media like that. So it's basically all started with electrochemistry. Okay? It's very clear. Without electrochemistry, we don't have gadgets. Now, okay, because the purpose, the principles, and the theories behind are all electrochemistry inside your gadgets, laptops, and mobile phones. So we need to discuss that we can have at least basic idea only, though not a rigid idea, because we are not a manufacturer of those gadgets, right? And we are not the designers of these gadgets and devices. Okay, we're just focusing on the basic theories and concepts of electrochemistry so that we can have knowledge why our gadgets will be operating and functioning properly, normally, something like that, functionable, and also we can have lights, okay, electricity, something like that, okay. Imagine the world without electricity, so oh my god, it's very dark. We cannot see clearly, okay. That's the point. Okay, now I will straighten out the drawing. Oh my gosh, I plan to make this short, but you know, after is kept talking something because there's discussing something like it, and because this is not really a formatting, blogging or stream that I have to discuss 1, 2, 3, 4, 5, 6, 7, systematized, orderly, functional discussion. This is on the spot, spontaneous. What comes to my brain says, the best technology I could relate to the topic, something like that. That's why my time will be extended most of the time. Okay. Be the reason behind why. Okay? It's not really intentional. It's really, it's really unintentional. It's just depending on the, information. Like that. Okay, guys, we need to review general chemistry lecture. Okay? Regarding oxidation and reduction. Okay? It's very useful in electrochemistry also. And electrolytes, physical property, what else? Acceptance of electrons, and there will be charged particles, charged particles, and then they will react with each other. Bingo, we have now the low polarity and low magnetic. Then electricity will be produced, something like that. Okay? It started with chemicals, really. Okay? Get the point? Okay, something like that. Copper, that's also chemicals. Okay? When you say water, that's also chemicals. When you say air, that's also chemicals. Anything that has weight and occupies space, that's all chemicals. And that part of a matter. Matter are composed of solid, liquid, and gas, and all chemicals are like that. It could be solid, it could be liquid, it could be gas. Okay? No other thing. Okay? We cannot deviate that. There are only 3 states of matter and 3 phases of matter. So if you can have scientific research and create your own phase, and you will undergo a lot of discovery, the test results, and you have your scientific research, and then you will become a scientist and introduce that to the world, and then you will be published in the books. Then we have another phase will come out. I discovered. Malo? Still 3 phases of matter because there's no another discovery of an additional phase. Okay, nothing ganon. Okay, my gosh. Not really sure because acknowledge lang talaga siya. It's not really that Michael Faraday. I'm not really that sure, but their contribution is related to electricity and also Mr. Ohms. Okay? It's gonna be, I'm not really sure, I'm not that really sure enough, but it's gonna be a contribution to Mr. Ohms, okay, Mr. Faraday, Michael Faraday. It really comes out in my brain cells, but not really that sure, okay, because this has the discovery of different scientists, okay, this will not appear immediately, okay, it's like this. Okay, we have, what we call this what? goodness. Okay? We have like this. Ganon. Okay. Like this. This is the first cell A. Ganon. Let's say this is A and this is B. Oh my gosh. Guys, I cannot promise to finish this vlogging because it will take a long time because there's a lot of, discussion for this. Okay. I think I'm gonna do this for 30 minutes only. Oh my gosh. Okay. A, B. Ganon siya. Okay. B. Okay. B, A cell and B cell, specifically voltaic or galvanic cell, something. Okay. So this cell A is composed of a solution of zinc sulfate. Yun. So zinc sulfate. Okay. And the other one also is a copper sulfate solution. Okay, copper sulfate. Okay, so the common here is the sulfates. So there's a neutralization effect between each sulfate in each cell. So we are not concerned with the sulfates chuba chuchu. Understand? Because the sulfates are common with each other. So we are focusing now to the elemental substance attached on it, which is the copper and the zinc. Okay? Something like that. And we need to put zinc metal like this. Just like this. Okay? Zinc metal. Ganon. Okay? Like this. And we need also to put copper metal on the other end. Okay, like this. Copper. Okay? Copper metal. But this is specifically zinc metal, sheet or plate. Okay? Or a conductive material generally. And other side also we have zinc. Okay? Or copper. Copper on the right and the zinc on the left. Okay, now. So this is open, of course. This is an open cell. Okay. We speak of cells composed of a solution, electrolytic solution inside. Okay, like that. Okay, now we will attach a wire, a path in which the electrons will flow from the wire. Okay, like this. Okay. Okay, like this. I don't draw exactly the appearance of the wire. It's just an illustration, okay? And then we need to put a bulb in the center, something like that. And then the wire will be also on the other end. Okay? Okay, let's assume that this is not yet light for homes, okay, or any other places, okay, for the purpose of lighting. Okay, something like that. Okay? Not yet lighting. We will explain why it will be lighting. Or something like that, okay? And now, since this is a solution, guys, so we need to put a little bit of a surface of the solution, the leveling, the level, okay? Okay, yeah, and then a solution. Of course, the solution will contact the metallic part, okay? And then it will produce electricity. But before that, there's a transfer of electrons. Okay, now we will review the principle of oxidation and reduction first, right? Because it's in here that we need to understand the transfer of electrons. Because if there's no transfer of electrons, and there's no movement of electrons, and there's no flow of electrons, we don't have electricity. And that's why we need to discuss what type of chemical reaction really is the movement of electrons, flow of electrons, and the transfer of electrons. Okay. And that's oxidation. Another paper. Oxidation is loss of electrons. Okay. It's sounds to be boring, but it sounds to be boring because most of the times we encounter this discussion in our general chemistry lecture, but this is a true to life story. Okay, you know, true to life story, this is really happening every day inside our home, inside our schools, inside our factory, plant, businesses, computer center, or whatever. Okay, this is really happening. We cannot just see the electrons, okay, traveling in the wire of the cable, but this is in a daily basis. This is really happening. Okay, okay, this is not a party or a birth every second, every minute, every hour, a day, months, years, a decade, a century, or whatever. Okay, electricity will be still here on Earth. Get the point? Because electricity sources are just in the planet Earth, within the planet Earth. Even though people will die, still the electricity will be produced over and over again. Okay, you know what? So this is oxidation. Okay. Oxidation is it's a process, guys, that will undergo. That can be easily understand when I'm talking. Okay, laws of electrons. Wait, laws of electrons. Guys, in chemistry lecture, we need to put the electron symbol is small letter E with underlined at the top portion of the small letter E. So this is loss of electrons like this. Okay, electron, loss of electron. And then if there is a loss of electron, what will happen to the oxidation number? What happens to the oxidation? Go up or will increase. Guys, when I was in college, I was really confused for this. Okay, but I found out through multiple of readings, research like that, because I am also a wide reader, especially about science. Okay, I really understand that this is opposite of oxidation number. The oxidation number is just the same with oxidation state. Okay, the synonym. In examination, there is also a question that will ask you, calculate what is the oxidation state of the compound or the element. So we need to use this principle. Okay, or what is the oxidation number change between from this to the product, from the reactant to the product? Then we need to use this because oxidation state and oxidation number, it has to do something with the charges. Okay, could it be electrons? Could it be positrons? Could it be protons, neutrons? Okay, like that. Okay. So basically here, electrons are being emphasized and only the protons. We don't tackle yet the positrons and the neutrons. Neutrons are electrically neutral particles. Neutral meaning there's a charge of 0 at the top of a single element. Okay, that's neutral. But usually, we'll never put 0, but it's understood to be 0 in chemistry. That means a neutral particle. For example, I will put zinc without any charge. This is electrically neutral, meaning to say, if you will put charge, could either be negative or positive, that will be already charged. Okay? Because when we speak of charge, it could either be negatively charged and positively charged. So now it will become an ion, I-O-N. So, if this substance will not be charged or will not be called as an blank is a charged particle. Your answer will be ion automatically. If this is a filling in the blanks question. Okay? Blank is the charged particle. Okay? Like that, as simple as that. Your answer will be ion. Then, blank is a chemical reaction where there is a transfer or movement of electrons. Your answer will be ionization chemical reaction. Okay? Just put that TION as a process from ions. Okay, ionization. That's why all elements or metals have ionization potential Okay, meaning the ability of the element to okay, ionization potential. And we have also the active for the interaction between the positive and negative. So that is electron charge, negative charge, right? That's why electronegativity. Okay. There's a number of electrons for that. Okay. So ganun siya. Okay. Loss of electrons, oxidation number, oxidation state. Okay. Will increase. I will just put arrow up to make it understandable always. Okay, during my discussion, something like that. Oh, arrow up. When there is a loss of electrons, so the oxidation state or oxidation number will go up. Okay, now what will happen to that particular element? Now, if this element oxidized, then what do you call this agent? Okay, this losing agent, as simple as that. For example, even water plus oxygen gas will produce 2 moles of water, blah, 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 so and so. In this chemical reaction, identify the reducing agent. Ganun lang. Charges and oxidation number and do the oxidation reduction chemical reaction. Then bingo, you can identify which is a reducing agent or not, or which is being oxidized or not, something like that. Okay, so reducing agent. Okay, that would be enough. And then for clarity for the symbols, when I was in college, I have an acronym for that, for easy memorization. So I have the LUOX. Okay, LUOX. Being oxidized and undergo the process of oxidation. The OX in the acronym have two. We can distinguish two. The oxidation process and it is being. We know there's also a reagent. AGENT. So we need to say reducing agent. For example, in this something like that, okay, then this zinc is being oxidized. And then this zinc also is a reducing agent. Ganon. Okay. So this is low ox. And now we go to the reduction. Okay. Reduction. Okay. The reduction, note guys, in ionization chemical reaction or in electrochemistry, we are referring to electrons specifically, not the protons, not the positive charge. Though we understand it gives the negative, then that particle will be positively charged. For example, I am zinc, I give electrons to copper. Then if I keep on giving my electrons, I will become positive somewhere along the way. Not, okay? Because I give the electrons to somebody else, something like that. So gain of electrons. And then the oxidation state or oxidation number will reduce. So arrow down. Oxidation state or oxidation number. Okay, guys? And now, since this is undergoing a reduction, then the element or the substance is being reduced. Okay, reduced. Okay. And then the agent is called, active part is the agent only. Okay. Oxidizing agent. If it undergoes some reductions of oxidation reduction. It's very clear now. You can write it down in a sheet of paper and then memorize completely. Okay, so that you can retain that in your brain cells for how many years. Okay, and understand that because it's very, very important in the oxidation reduction. And then we go now to our illustration for the volt. I have still 13 minutes to. So I'm very sleepy. Shut up. Okay, ganon. Okay, so zinc here, zinc, okay, zinc, okay, okay, we have the copper, cell D, yes, cell D, copper, okay, multiple of copper, and then the zinc, okay, this will become, the copper will be a charge of originally positive 2. Okay, here. Actually, this is also zinc positive too. It is a weak pooling of electrons in the side of the zinc. Okay, weak pooling of electrons. Okay, but the copper side has a strong pooling of electrons. Meaning to say, this copper will really pull the electrons from the zinc. Okay, so we have now the half reaction for this between to one another. The half reaction. So zinc, if that is already a solid zinc, ENS. Okay, CNS solid. Okay, now this copper will pull the okay. Zinc like this. Positive. Okay. Zinc solid, also zinc positive 2. Okay, and your copper, the other cell, we have the 2. Okay, this will become now plus 2 electrons because they receive the 2 electrons coming from the zinc. Okay, so plus 2 electrons. Okay, is equals to copper solid like this. Okay, so meaning to say the zinc will lose the 2 electrons. So electron here, the metallic plate of the copper. Okay, zinc. Okay, simply charge the zinc. Okay, but actually the zinc has also positive charge originally. How they transfer electrons and how they receive. Okay, because this zinc originally, see, zinc, copper on the other side, it will produce a cuprous or copper positive 2 and zinc positive 2 when it is in the solution. Because the point, because remember, this is a copper sulfate solution. Okay, so this zinc, a zinc solid or metal state, because it is really giving the electrons to the copper. Okay, the copper will receive the like this. Here, copper is holding the plate, and then after that, transferring the electrons, the copper solid also in the placements of the electrons, man. Okay, like that. Pwede mo siyang charge positive 2. Okay, now if the zinc solid, it will become a charge, positively charged particle, and now the other solid, okay, 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 okay. Now, if you keep on giving the reverse, okay, we are referring to the from there. That's what it's called. In which the electrons are passing, going out. Supposedly, you call this as a cathode also, but no, it's anode because from there and go to the another end. Actually, you will be confused sometimes, right? The region or the path is different. It is the cathode is a region or a space in which going out will be receiving or accepting the electrons. We need to say if it is a cathode that is accepting electrons, okay, and if it is an anode, it is giving all the protons. Okay, always electrons are referred. Like this. Get the point? Okay, cathode is the one who will accept, it's a region or a cell that accepts the negatively charged particles. But the anode is the negative transferring, something like that. Meaning it's not referring to the particle, but it's referring to the path, something like that. That's the this cation. This is the terms of particles. If I say positively charged particles, that is a cation. But it will flow from anode. Reverse. Okay, now, if it is a negatively charged particle, it is called an ion, but it will be flowing to the cathode. Also, reduction is a process and the agent will be called as the oxidizing agent. In fact, it should be supposedly an oxidizing agent, but it's a reverse. Just like this also, there's a reverse terminology for this. And you have to understand because sometimes it will confuse you sometimes. Okay? Like that. Okay? So, this zinc, okay, will give off the electron such that it will never give anymore. It will consume. Okay? And this negative also, okay, copper will also become highly negative or electronegative. So accept, and then will come also electronegativity. So what will happen? Supposedly there will be no electricity water in the glass. If you keep on powering water, it will overflow. If you give too much work for the person and he can no longer do the task because so many tasks given to him or to her, he cannot manage anymore the task you've given to him. So you should adjust and give at his own convenience and comfort. How much can he finish like that? You need to try because it reached the level or the limit of their capacity to work, something like that. The same also here with the with the cathode and the anode, the positive charged particles and the negative particles. Time will come, it's like that also. Because this copper positive will keep on pulling action. Okay, by the way, I forgot. If this zinc will transfer the electrons, and now that's the time the bulb will light. Sorry. I forgot. Okay. It keep on transferring the bulb will light. Okay, so you put like a movement or electrons flow in a wire or in a path. Okay, that's the time we need to put a bridge, another path, which is what we call a salt bridge. You know, salt bridge. Meaning to say, you need to introduce a salt bridge in order to neutralize and to stabilize the chemical reaction of these two. Because in fact, these solutions from A and B, from each cell, have common polyatomic ion. Common, sulfate, is all for negative 2. So in the first place, they will never stabilize at all also. Okay, because the also another protoatomic ion there that must combine with this other polyatomic ion. The sulfate. So the sulfate already will never react. Okay, so what will happen now? So we need to introduce a strong electrolyte. What is the best example of a strong electrolyte? This is sodium chloride. Okay. Okay, so you have to put a salt bridge, something like that. Okay, I will draw also another salt bridge. Salt bridge. Okay. In the topic of electrochemistry, guys, this is referring to electrolyte. The best example for this are salts, really, and the very station, so that your production of electricity will be stabilized, something like that. Okay, salts. Okay, like this, and you put that here, your sodium chloride, so say NaCl, right? And you put that on the bridge. It will not be what do we call this one in English? Abrupt giving off this reaction of chlorine and sodium. So it will just be flowing smoothly. That's why cotton is being put for the absorption requirement, something like that, so that there will be no abrupt. Actually, you don't have to prove it, but it's already done experimentally in the past by our scientists. Okay, like that. So we need to put cotton, and then the sodium chloride will be here now. Salt bridge, sodium chloride. Okay, guys. And now, sodium chloride as I actually, and this voltaic cell A or galvanic cell A. Okay, voltaic cell A, guys, is also known as, and then in voltaic cell or galvanic cell B, that is reduction cell. And each cell has its own half, a complete one. And after that, you have to add a 2, and that will be the complete reaction. That's why it's called half reaction. Okay, because it's not yet the complete reaction. and then you have to cancel out the number of electrons if you add that one. Okay, meaning to say already stable. Okay, because there's no charges at all in the product, the chemical reaction in the cells. Okay, like that. And when it become now like that, then electricity will come, right? So, ganon siya. Now, I don't have to put that because hindi siya masulod. Okay, so chloride will split into sodium ion positive and chlorine negative. Now, where does chlorine negative go? Okay, think of it. The zinc is a neutral at first, that is, okay, like that. You get the point? The zinc is neutrally at first when it is not yet going to the solution. And it go to the solution, it is become a solid in a metal state because the neutral atoms will produce a metal state na siya if it will become ionized into a solution, something like that. So it will become now a zinc solid. Okay, something like that, and it will not produce a charge and electrons. Okay, and it will be transferred. It is now becoming more positive as it will give off more electrons to the copper. So as he gives more electrons to the copper, it becomes more positive. So to stabilize and to neutralize, right, we add sodium chloride. The chloride ion will go there because the chloride have a negative charge. This is the one who stabilize. So in this manner, electrolyte solution will become in. Okay, so not overly positively charged now because of the chloride negative will act, and then the reverse also will hold true. And the copper is more receiving the electrons, so it will become overly charged with negative. Okay, then it will become highly electronegative. Okay, something like that. And then the sodium ion will go there also. So the sodium ion will stabilize and neutralize charge, and will come. It will stop the electrochemical reaction. Okay, so the current also will stop if the time comes, something like that. So it's an electrolyte magod. Okay, like that, and the sodium ion connecting the solution. Okay, it's in here. There's a zinc, there's copper, something like that. Okay, so the current that passes through the solution, okay, will just be normalized, and electrical energy will be steady, something like that, and the bulb will not stop lighting. Okay, like that. Now we have this reaction, right? We introduced in the introduction, and now we have to add these two reactions. What will happen? These two half reaction in the oxidation cell A. Okay. Now these are each half cell reaction. We will add one. What will happen? We have now a complete reaction. We are having now our complete electrochemical reaction. Okay, then we cancel out the electrons, both the two electrons, because it's in the other side. The other two electrons to the other side, and the other side like this. By algebra, if it is two the same component, whatever as long as it is in opposite, okay, and the same charge, zinc solid, all reactant, of course, zinc plus copper plus 2 is equal to, okay, this is our final, okay, zinc solid plus phosphorus positive 2 or copper positive 2 is just the same. The reaction that will produce electricity. The purpose only of sodium chloride is to stabilize and neutralize the electrochemical reaction so that there will be no overcharging of the electrically charged particles, sorry. Okay, like that. Time will come, the electricity will stop. And this is also in our room. This behavior is always having this behavior, but we cannot see only. But it's behaving like this also. Okay, in which this principle of producing electricity in our home, in our schools, in our plants, in our factory are happening day by day. Okay, something like that. We cannot just see it, but it works in this way. Okay, for neutrons. Nobody can see that. It's a very, very tiny particles. The protons and the neutrons, and the outermost shell of the electrons, and the shell of the nucleus is the electron. protons. That's why also this is the very best technical reason for electrons shell of the nucleus. It has inside the nucleus bonded together, which has almost 27 kilograms. 6, 20 times to the negative 19 columns, something like to negative 19, what? Maybe it will be interchanged. You don't know like that. But the electrons 9.4, let's say, what's that? 1.67, something like that. In electrons, and I'll show you the colors also. But for the protons and neutrons, forgot a little bit. I think it's gonna be 1.67. I forgot. Negative 19, something like that. Get the point? Like that. Now, so that's the basis already, right? I understand already the discussion of the electrochemistry. It's in here also, guys. We need to know the relevance of what do you call this one, guys? Conductance, inductance, capacitance. So we have capacitor, and then the resistance. Also, that's why we have specific resistivity, and we have also specific conductivity. Am I correct? Conductivity, which is 1 over ohm is equal to ohm negative 1. It can be called also as mho, MHO. It's the same also with 1 shell, specific conductivity. Specific conductance or conductivity. Derived that term there. Shannon is the unit of conductivity. So SIENENE, Shannon. Because usually Shannon as a unit will never be used on the centimeter. Or shall we say the meter? But usually centimeter is being used. Length of 1 centimeter. Volume. Centimeter squared plus centimeter is equal a volume. Something like that. So that's why the molar conductivity is equal to the volume times is equals to the molar conductivity. Molar meaning the ions. The conduction of all ions. That as per 1 mole of electrolyte in a specific volume of aqueous solution. That's molar conductivity. And then the specific conductivity will be a conductance between 2 electrodes. Of the two, we have to attach 2 metallic plates, so that we call with a measurement of 1 centimeter distance apart for the length, and the surface area of conductance or specific conductivity. So it different concentration expression na siya talaga. Concentration expression could either be molar, normal, or the molarity, and normality expression. But the common is the molar concentration. That's why it's called molar conductance or molar conductance or molar conductivity. Ganun, di ba? Since we know also in the first place that resistance is directly proportional to the specific resistivity times that over the surface area, which is that square centimeter. That's why K is equal to resistivity or specific resistivity, times the L, and the area will be the surface area covered by this solution, electrolytic solution inside the cell with 2 metallic plates with electrode each. Ganon. So ganun siya. And then you can also derive an equation for that, since you know that the conductance is the reverse of the resistance. Remember that in your high school? The conductance is the reverse of the resistance. So C is equals to 1 over R. Then compute for the R, substitute that to the original equation I told you, which is R is equals to the K specific resistivity times the cell constant L. We can have another formula through that derivation. I will not do it because it will take a long time. I'll just discuss, and then you can have another formula for C conductance, which is equal to the another K, which is the specific conductivity, okay, times, okay, L over A, ganon. Okay, units, you will plug in the units and you can have the units. As far as I could remember, the units will be, it's gonna be as I told you early, you can distinguish that if you plug in the units one by one in the equation, if you forgot. Okay, but I am sure that the ohms will become negative. Okay, because there's length over area man sa formula. Okay, so it will become now, it will now become centimeter negative 1 na lang siya because the length in the numerator and the area will be cancelled man siya. So what will left is the centimeter in the denominator. So it will goes up, then it will become centimeter negative. So the unit pala is times centimeter negative, or because 1 Shannon is equal to 1 ohm negative equals to 1 mho, MHO. Always take this in your brain set that the reverse of ohm is the mho, MHO. Okay, and then equivalent to 1 Shannon. Okay, who knows? There's a question like that in the future. How many Shannons in 35 mho? You cannot answer because you don't have that basic, conversion factors in your brain cells. What if there's no books, there's no handbooks, and you have no data in your cell phone? How can you answer? The only way is to memorize, right? Okay, there's no other choice. Okay, like that. That's the point of, memorizing the basic formula, because not all the time we have our cell phones, our data, we cannot Google, okay? Sometimes our cell phones will be left in the room, okay, if we don't have cell phones, and then we don't have load, like that, and you don't have computer, and you should not also ask, what is the value of 1 Shannon? You cannot answer because you never memorized. Okay, so at least you will memorize the basic lang. Basic lang naman talaga. Okay, for electrochemistry, ha? Okay, the Ohm's law, okay, is equals to I, the work, okay, that electrical formulas for power is equal to work over time and electricity. Okay, because you can substitute too much definition for that for the work. Okay, understand? It will become work is equal to like this because you know also that the current is equals to the electrical charge over the time. You know one current ampere is equals to the electrical charge coulomb over the time. P is equals to work over time. Then you can have another formula also for power. Actually, there are 5 formula for power. Okay, because of that thing, you can play that around your derivation. But I am sure only the basic one. Power is equals to work over time. Okay, something like that. Anyway, you can derive, no problem. If the in the question is usually the question will say calculate the electrical current. So use that formula. Sometimes you have to break also the loops, LOOPS. There's a circuit like that, and you break the loop and you cut that one and determine what's the capacity of certain loops. Something like that. Okay, multiple loops in practical electricity, if you can remember, right? Aside from the Ohm's law, we have also the current exactly figured out how can it be like and 2 laws. Sorry, difference is we use chemical reactions. And basically, when you produce electrical current, there's chemical reaction already. Okay, because the wire contains a metal. It could be but it's solid also are chemicals. Like that. Okay, like this, the chair. It's composed of carbon, oxygen, and hydrogen. If you take the sample and analyze, okay, because this trees is coming from the photosynthesis, something like that. You know photosynthesis? So we call this one ATP, adenosine triphosphate, giving energy. And then this adenosine triphosphate will produce carbohydrates, and then it will go to the plants, and then the human being will eat the plants. Okay, and these plants also will be manufactured to become paper, to become a bag, to become a chair, to become a table. So it originally starts with a chemical. So that's why all things in your room are chemicals, starting with chemicals. Okay, you get the point? So the chemical terms is not literally means and this one, this microphone, this board, everything. Because in the first place, the first oxygen, we cannot live. Understand? Through inhalation, chemistry of atmosphere. Okay, oxygen and noise. So I love chemistry because without chemistry, when I was young, scholarship in chemical engineering. I don't know what to tell them. Okay. Okay, that's it. Okay, so any questions so far? Then you can comment down below the comment section or you can sorry guys. 11 ba yung na kayo? Or you can issue an error. I will issue error statement because I'm not perfect. MSA, it's not prepared, it's not outlined, it's really on the spot. Though I read every other problem solving, I choose any. Okay, like that, and I solve first. Again, if wrong, then I will go to the solution proper. If correct, then perfect. If not, we can go back to the solution where I am wrong, something like that. Okay, natural process. Okay, like that. Okay, so sorry, most of my vlogging will take longer time because of that reason. That's crafted on the spot. Okay. Sometimes I don't have planned and I will never do that. It's gonna be like this. So erratic. Erratic and movement of the by the way, class, we can also determine the flow of electrons. I think it's gonna be under fluid dynamics. Static, sorry. Fluid static, like that. Because there's no fluid in the path, but it means like that. Sometimes it's not literally, but it's the theory will not be limited to flow liquid or good shot. It could be either electrons. What is the charge? Now, if you spot me now, if I will ask you, what is the state of a charge? It is a liquid or gas? You cannot answer, right? Because we cannot see, we cannot touch, we cannot smell these electrons. So we cannot define this as a state of matter because as like oxygen, like that, you can never see the oxygen, right? Okay, by our naked eye. Okay, we cannot see. Purely imagination. Okay, we can something like that, the behavior, but there's no story like that. It's already a theory. Thank you so much for watching this live stream for electrochemistry, and then budding for the. Ito pala, mayroon pa tayong petrochemistry. Petrochemistry? Petroleum, chemical reactions of petroleum. Char.